Hello everyone. Today I will show you an instructive double integral problem where we will talk about transformations, the Jacobian, and changing the order of integration. Just a little short mini lesson on that. So let's get started. The problem says use the given transformation to evaluate the given integral where R is the triangular region with vertices 0, 0, 5, 1, and 1, 5. And we're given the double integral over the region R of x minus 6y dA. And our transformation, or our equations that relate x and y to u and v, are x equals 5u plus v and y equals u plus 5v. So off camera, I went ahead and sketched this region R with its vertices, and R is on the xy plane, and we're going to transform this region R into a new region S, but this region S will be of the coordinate system UV. So with that out of the way, let's get started. The first thing that I always like to start with is the Jacobian. So the Jacobian is always necessary when you make a change of variables or a transformation. So here we're changing our variables from x and y to u and v, so we're going to need a Jacobian. And the Jacobian is simply a determinant of a matrix, in this case a 2 by 2 matrix, of the partials of x and y with respect to u and v. So I'll have a video coming out soon that goes into more detail about the Jacobian, but for now let's solve the entries of this determinant of this matrix. So the partial of x with respect to u, well, when we do the partial of x with respect to u, we hold v constant, so that will go to 0, and the partial of x with respect to u, that's just going to be 5, because the derivative of 5u is 5. And same for v. Now we do it the other way around, where we hold u as a constant, so 5u goes away. Derivative of v, that's just 1. And we do the same for y now, and the partial of y with respect to u, we hold v constant. Derivative of u, that's just 1. And for the partial of y with respect to v, we hold u constant, and we take the derivative of 5v, which is just 5. And so now we can do this this determinant of the matrix, right, where we substitute the values we just found. So partial of x with respect to u, that's just 5. Partial of x with respect to v, that's just 1. Partial of y with respect to u, that's also 1. And partial of y with respect to v, that is a 5. And the way that you solve these determinants is you do, I'll say it first and then I'll show you in more detail what it is, but you do a times d, so AD minus B times C. And put simply, each of these entries of the matrix, we can label them with letters, and we label them like this. So this one here, this is A, this one is B, right? Sorry. This one is B, this one is C, and this one is D. So you can see what values those entries have. So entry A is 5 and entry D is 5. So 5 times 5 is 25. The way I like to do it also is I draw this diagonal arrow like this, and I do those I multiply those corresponding entries, so that's the AD. And then I do this diagonal like this. So this is 1 times 1, or B times C. So we're going to subtract 1, right? And 25 minus 1, that's just 24. So hope that made sense. So now we found our Jacobian, and that means we can find out what our dA is going to be. So later we'll talk about changing the order of integration, but for now I'll leave it as du dv. So our dA will be equal to the Jacobian, which is 24, and then du dv. So let's put a green box around that so that we can hold on to that for later. We will need it. And the next step would be to rewrite the integrand. So our integrand is x minus 6y, And I've also done this step off camera because it's just substitution or simple algebra, right? So we basically take this equation for x, where x equals 5u plus v, and this equation for y, where y equals u plus 5v, and directly plug it into this integrand wherever we see x and wherever we see y. So doing that, we get negative u minus 29v once you distribute everything out and combine like terms. So we'll put a box around that. I know I went fast through that step, but this video is mainly to focus on the calculus 3 concepts. So I've done some of the algebra and substitution off camera in the effort of time. But if you have any questions, just feel free to leave a comment, and I'll be happy to write you a comment explaining it, or maybe even a separate video explaining it in more detail. And now that we have our integrand written in terms of u and v, because that is what we're taking the integral of, right? du, dv, or dv, du. We want our variables in terms of u and v, not x and y. We determine the region S. So we were given 3 vertices in region R, 0, 0, 5, 1, and 1, 5. And we have to map those vertices to vertices in the UV coordinate system, or in our region S. So our first point, 0, 0, we have x equals to 0 and y equals to 0. And when we plug that into this equation that we were given, right, x equals 5u plus v, y equals u plus 5v, we get a system of equations, or a system of 2 equations. And there are multiple methods for solving things like this. There's elimination. The method you're going to see me use in this video is substitution, because it's going to make the most sense to the most people. But the method I actually recommend would be to use a matrix and row reduce it. I'll have a video coming out shortly of how to use your TI-84 calculator to input a system of equations like this in your calculator and row reduce it and get the answer. But you can look closely at the work here, but basically what I did here is I just did some substitution. So I took the second equation and solved for u and got that u equals negative 5v. I plugged that negative 5v into the first equation and got that v has to equal 0. And once I knew v equals 0, I brought that back to this equation here, right, u equals negative 5v, and got that u also has to equal 0. So our first mapping of our first vertice to the UV coordinate system is 0, 0. So we'll put a green box around that. Okay, and then we have to do that for our other 2 points too. 5, 1 is our next point, and I did the same thing, right? Plug x equals 5 in here, y equals to 1, get this system of 2 equations and 2 unknowns, and whatever method you're most comfortable with. Again, I think matrix is the most foolproof, because you can't make the mistake. You know, there are some steps here, you know, to getting the right answer, and you know, the more steps you add in this process, the more likely you are to make a mistake, and also the more time you're going to spend if you're taking an exam. So you want to be mindful of how you spend your time on an exam, so you have the most time to answer all of the questions to the best of your ability, right? But once you go through this, right, this little substitution, I got u equals 1 minus 5v, plug that in, you get v equals 0, plug that back into the u equals 1 minus 5v, you get u equals 1, and we get our second mapping, which is 1, 0. So we'll put a box around that. And then our final mapping here is the vertice 1, 5. Same thing, right? X equals 1, y equals 5, system of two equations, 2 unknowns, right? U equals 5 minus 5v, v equals 1, u equals 0, right? And then we have our third point, 0, 1. So again, I know I went so fast through that part, but the point of the way we found it is we had a system of 2 equations, and you have to know how to solve those, either using elimination, like I show here with all this work. You can pause, or if you don't understand it, ask a question in the comments. I'm more than happy to explain it. In this here I did substitution, but again, the most foolproof is the matrix method, and I'll have a video coming out explaining how to do that on the TI-84. So look out for that. But now we have our 3 vertices, which means we can draw a picture of what this is going to look like in the UV plane. And it's worth mentioning that in this case, there were no x squareds or anything like that that might alter the shape of this, right? We only have, these are just simple equations here. So, but there are other problems where you might have, I don't know, maybe an x squared in there, or x equals to u squared, right? And so you want to be careful because now your mapping is going to look like it's going to have a curve, right? Or something's going to be different. But in this problem, it's really, really simple. We're starting with the really, really basic examples here. So we end up with this triangle, right? And I've drawn it off camera here with all of our vertices 0, 0, 1, 0, and 0, 1. And so now we have a choice of the order of which we want to integrate this problem. We can either do du dv or dv du. And I'm going to use this opportunity to give a short mini lesson on changing the order of integration, as I think this is a really basic problem, and it will really, it might help patch up some holes in people's understanding of this concept. So let's look at both of these cases, right? So if we did du dv, we'd have the integral, right? And they're going to have a bound here and here. It's going to be with respect to v because v is our outer integral. I'm going to leave some space for our u, which is our inner integral. And then I'll put our integrand from up here, negative u minus 29v, right? So negative u minus 29v. And then I'm going to put our dA, which is our 24 du dv. Do not forget to include that Jacobian. And when we do it in the other one, right, we're going to swap the order of these two. So you'll see what I mean later. And now we have to find out what the limits of our integration are for u and v. So when we start integrating with respect to u, right, or if u and v are confusing you, you can think of this coordinate system right here as x and y. And anytime you see x or see u, replace it with x in your mind or whatever helps you understand this. But when we integrate with respect to u first, we start from left to right. So the leftmost point of this triangle is here. And we go all the way until the rightmost point of our region. And what you should notice is we start from u equals to 0. All right, so no matter what point we start on when we're integrating this triangle, we're always going to start from 0, okay? And that's true no matter where we start. We start here at 0, right? Anywhere else it's going to be 0. But what happens when we reach the rightmost side of our region? Well, we hit, excuse me, I don't know why that happened. We hit this line here, right? And our u values are going to be different depending on, where we, our v values are going to be different depending on which u we choose, right? If we choose this u right here, let's say this is 1/2, right? We're going to get a point like right out here somewhere, right? But if we choose 1/4, we might get over here. And so how do we represent that change of v, right? Well, first of all, we can notice that we can write an equation of this line. So this line is of the form y equals mx plus b, but I'm going to obviously change the variables because we're using this in a u and v coordinate system, right? So we have the equation v equals mu plus b, right? V is our y, u is our x, and that means that v is equal to, our slope here is -1, so negative u, and our y-intercept is +1, right? So that's the equation of that line, and that's actually going to be what we use to write our upper bound of our integrals. So, but what we have to be careful of here is we want this for u, right, not for v. So let me move this up a little bit just to make it a little bit neater. We have to solve this equation for u. So let's do that. We can just, swap sides here. Swap sides, swap signs. So we get that u is equal to 1 minus v. And that's actually what's going to be our upper bound. So our upper bound here is 1 minus v. We're going to go from 0 all the way over to the line 1 minus v. And that is how we're going to find our bounds for u. But now if we want to find our bounds for v, right, for v, we're going to see, what, where does v range from, basically. And v will always just range from, change back to purple, v will always just range from 0 until 1. So along this line, you could think of it also, right? All those values of v are going to be between 0 and 1. So we have a very simple outer integral here. It's just 0, 1, right? So that would be if we did du dv. But now what would change if we did dv du? Well, let's set up the integral. So we got this integral on the outside. This now is going to be our u. And this one here is going to be our v. And then we have the same thing, our negative u minus 29v, 24. And then the difference here, I'll even mark it in blue, is dv du. So now we have to integrate this with respect to v. First, we have to change our order of integration. And when you do that, you have to change the limits of your integral. So let's analyze this same picture. I'm going to leave the turquoise arrows there as, as an example of the first part of this. But now let's analyze what would happen if we chose to integrate with respect to v first. So now we do from the lowest part, right, here, all the way up to the highest part. So our v is going to start always at 0, right? But now our v is going to range to this line right here. So we can represent that by the equation right here, right? The same equation we used before for u, but now we're going to solve it for v. And I hope you guys don't mind. I'm just going to move these variables around here so it's 1 minus u. But it's the same thing, right? So up here we're going to have 1 minus u. It's going to go from 0 all the way up to the equation of this line, which is v equals 1 minus u, right? From 0 to 1 minus u. And then if we look at what happens with u here, well, u, I'll pick a different color, u just ranges from 0 to 1, right? Any value of u we pick, we're going to get either a number, we're going to get any number between 0 and 1, right? Infinite amounts of numbers, right, technically. So that would be the difference in our integral setup here. So we have to choose which one we want. And for the sake of this problem, I'm going to do du dv. Just simply because alphabetical order, it's just how I'm going to choose to do this problem. But just so you know, if you did the other way and you integrated basically the exact same way, because the only difference here is, 1 minus u and 1 minus v, you're going to get the exact same answer. So let's actually solve that integral. We've done all this setup, and now we actually have to solve the integral. So let's go ahead and do that. So we have the integral of 0 and 1, or from 0 to 1, and the integral from 0 to 1 minus v. This is our region S of negative u minus 29v, 24, that's our Jacobian, du dv. All right, so when we deal with, I'm sorry for those blue lines, everybody. I'm going to find a way to, either I'm going to change my software or something like that to get rid of those lines. But if you have a solution, just let me know in the comments. But I'm sorry in advance. I know it's kind of annoying. So when you have something like this, you can actually bring the constant out to the front. So let's do it. Let's go ahead and do that. So we got 24 integral of 0, 1, integral of 0, 1 minus v, and then minus u minus 29v du dv. And so now let's just focus on this inner integral first. So this would be our inner one, right? Our inner integral. And let's solve that first. So I'll just mark that by doing a side work here. So we're going to do the side work of the integral of 0 to 1 minus v of negative u minus 29v du. So how do we do this? Well, when we integrate with respect to u, v is just a constant, right? So that part's the easy one, but using the, I believe it's called the power rule for integration. There might be a more technical term for that, but basically this u, we're going to keep that negative. It's kind of like a negative 1 in front. But then we add 1 to the power, so 1 plus 1, right? And that's going to be 2. So I'm just going to do that. It's going to be 2. And you're going to divide by that new power. So it's going to be negative u squared over 2. And then we have this minus 29v. Well, that's just a constant. What's the integral of a constant with respect to a variable? You just add a variable. So 29v u, and we're going to evaluate this from 0 to 1 minus v. So let's go ahead and do that, right? So every time we see a u, let's well, I'll show you. Well, you guys should see this. Basically, when we put in u equals to 0 here, these u's are being multiplied in, or one's actually the numerator and one's being multiplied in. So that whole f of b minus f of a, that whole f of a part where we're substituting in the 0, that's just going to be 0. We're just going to subtract 0. So for the sake of time, I'm not going to write that, right? But we're going to do the 1 minus v part. So that we're going to focus on. I'm just going to mark that by doing like a x or something through this 0, because it's not going to matter. You know, it's going to just be minus 0. So everywhere we see u, let's substitute in 1 minus v. So we get 1 minus v, and this is squared, over 2 minus 29v times 1 minus v. And we can further simplify this. So first of all, 1 minus v squared, you can think of this as 1 minus v times 1 minus v. And then you just FOIL everything out. So we got the first. So this is going to be, I shouldn't put an arrow there. I should actually put equals, because they're equal, right? They're equal. So the first, 1 times 1, that's just 1. The outside, which is 1 times minus v, which is minus v. The inside, which is minus v times 1, which is minus v. And then the last, which is minus v times minus v, which is plus v squared. So that can also be written as v squared minus 2v plus 1. So let's replace the 1 minus v squared with that, and we get minus v squared minus 2v plus 1 over 2. And then we can subtract 29, well, negative 29v times 1, that's just negative 29v. Negative 29v times a negative v is plus 29v squared. And the way I'm going to further reduce this is basically write this as negative v squared over 2, negative 2v over 2,
or yeah, basically, this is going to be a plus because we bring in the negative to all of these terms here, right? So plus 2v, and then minus 1/2 minus 29v plus 29v squared. And this can be reduced down, right? So we got, this is going to cancel, 2v over 2. That's just going to be v. And negative v squared over 2, that's just negative 1/2 v squared. Add a 29, you get 28.5 v squared. That as a fraction would be, let's see, 57 over 2. Let's just check that. So 29 times 2, that's 18, 58, minus 1, yeah, 57. So we have positive 57v squared. 57 over 2, excuse me, v squared, plus v minus 29v, that's just going to be minus 28v, and minus 1/2. And so that is the solution to our inner integral. So now we can put that back into the original integral and take the outer integral. So now let's put it back in, and we have the integral. Oh, we can't forget the 24, right, on the outside integral. And the outer integral went from 0 to 1, right, from 0 to 1. So we're going to make this one here 0 to 1. And we're just going to put in the 57 over 2 v squared minus 28v minus 1/2. And to take this integral, or I'm sorry, I also got to put the dv on here, right? So to take this integral, let's first start by writing 24 times, and then I'll put in brackets here. This will be what we're going to, the result of the integral. So the 57 over 2 is going to stay, and so we can just write that here. I'll do it in 2 steps just so that it's really clear. V squared, the integral of v squared, well, you just add 1 to the power, so that's v cubed, and divide by the new power, right? So it's v cubed over 3 minus 28v, so the 28 is going to stay. And then the integral of v, well, you raise the power, that's v squared, divide by the new power. And then we have the 1/2. The integral of a constant is just the constant times the variable you're taking the integral with respect to. So this is negative 1/2 v. And this whole thing is going to be evaluated from 0 to 1. So let's just look at this, right? Obviously, all of these terms, they're being multiplied by v. So if v was 0, right? If v was 0, then all of these terms would be 0. So basically the back half of this f of b minus f of a, the f of a, it's all going to be 0. So we're not even going to look at that. But let's look at what happens when v is 1. So this will be 24 times 57 over 2. I'll put this in parentheses. Yeah, 57 over 2 times, and this is going to be 1 cubed divided by 3 minus 28 times 1 squared over 2 minus 1/2 times 1. And what does that evaluate to? This will be 24 times 57. This is 1/3, right? So just multiply the denominator. 57 over 6 minus 1 squared is 1. 28 times 1/2, that's just 14. And then minus a 1/2. And now we can just combine those terms in the middle there. So let's give everything a common denominator. So 24 times 57 over 6 minus, so 14 times 6, just has some side work here, before 2, that's 684. So 84 over 6. So let's do that. 84 over 6. And then 1/2 over 6 is just going to be 3 over 6. Okay, so now we can just, subtract them. So 57 minus 84. That's going to be, well, I guess we could just take the difference, right? We could do 84 minus 57, right? And then we get 14, 7, 27. So negative 27 minus 3 is negative 30. So this here is negative 30. Negative 27 minus 3, which is negative 30. Negative 30 over 6 is negative 5. So this is 24 times negative 5, which is negative 120. And this is the answer, negative 120. Sorry for the last computation. I was just stuttered a little bit. But the point is, that was a long problem. There was a lot going on here. Just to recap, we were given a transformation of x equals 5u plus v and y equals u plus 5v. And we're going to transform a region R, which is a triangular region with vertices 0, 0, 5, 1, and 1, 5. We transform it into a new region we're going to call S, which is of the coordinate system u and v. We take the Jacobian by doing the partial of x and y with respect to u and v and computing that determinant. And that gives us our new dA. We rewrote the integrand in terms of u and v instead of x and y. And then we found out the mapping, the corresponding point in the UV plane of every single vertice that we were given in the problem. And once we had that, we drew a picture and we did a small mini lesson on changing the order of integration. And we decided to go with 24 du dv as our dA here. But if you were to go through the other integral, you would get the exact same answer. And then we just did some math to reach the final answer of negative 120. So a lot of steps, but I hope you learned something from this video. I know it was long, but if you did make it to the end, I just want to thank you. This is my first video on my channel, and I'm really excited to bring you guys educational content related to math, physics, engineering, technology, coding, basically whatever I feel like is needed. I'm going to make a video on, and I'm going to try to post. I'm going to start with a goal of once per week, but I'm really feeling motivated, so I'm going to try to put out a video every day. But I hope you guys enjoyed. If you have any feedback that you want to leave on ways I can improve the video, things I can do to make it more watchable or digestible, or problems for me to do, please let me know in the comments. I'm really open to suggestions and feedback. And that's all for right now, guys. I hope to see you in the next video. Have a great rest of your day.